Hello, hello. We are looking at sketching rational functions. Before we can sketch them, though, we have a bunch of things to talk about. So I wanted to start here on the note sheet, which hopefully you have handy. If you can print it, that's great. If you can't, make sure you have it on a tab somewhere where you can refer back to it, because we're going to be using this quite a bit. So first of all, if you look at the top here, it looks super intimidating. It's like, oh my gosh, what the heck is this thing? Guys, it's just fancy math language for saying a rational function is basically just a fraction, okay? That's really all it is. So the only things that you need to have are, we're not going to be dealing with, for our purposes, we're not going to be dealing with any variables raised to fractional exponents. So we're just going to have some polynomial on the top divided by some polynomial on the bottom. That's pretty much all it is, okay? So don't let all this mumbo jumbo in here confuse you, okay? That's all it is. It's just polynomial on top and on bottom, okay? As always, the denominator can never equal 0. So we know that. So first thing we're always going to do is we're going to factor the numerator and denominator. We are going to take a look at our domain. So we have done this before, so this will be a good review. Remember that I can never let that denominator go to 0. So any number that makes my denominator be 0, I have to exclude it from my domain. Okay, so that's old news. What might be new news, though, is this idea of a whole. So what does that even mean? What is going on? Well, it turns out that when we have some of these rational functions and we graph them, what can happen sometimes, let's just say if I'm trying to graph and I'm just making a graph, sometimes, let's say my graph looks like that, okay, fine. But let's just say at one particular value, it's going to make something break, okay? What happens is we get a little tiny hole. We get a little tiny hole in our graph. So it might look something like this. And then we have a little, oh, it's so hard to do this on with my little tiny, oh no, let me try again. Hold on. Oh, that's as good as it's gonna get here. Okay, you just have this little tiny hole in your graph, okay? We'll talk more about them. Finding them is actually fairly easy. And then the graph, you just put a tiny little hole, boop. You just don't have, your graph can't exist right there because it would make something break. So it's going to give you a 0 in the denominator, something's happening. Okay, so let's read how to find them. So it says here, if a factor cancels between the top and the bottom, there is a hole in your graph at the x value determined by that factor. So I'm going to go through this. I'm going to show you exactly how to do it. We'll look at some examples. But yeah, so basically that's what we're referring to. When we say a hole, it'll make more sense as we do our examples out, okay? And we're also going to be looking at vertical and horizontal asymptotes today. Slant asymptotes will come tomorrow. So we have mentioned these in the past. Remember, an asymptote is a line that a graph gets infinitely close to but never actually touches. So it'll just approach those lines, so you can have them vertical and horizontal. So for the vertical ones, once factored, any factor in the denominator that does not cancel with the numerator becomes a vertical asymptote at the x value determined by the factor. Okay, so again, we'll go through this. That's basically saying, if I had, for example, x plus 3 in my denominator, I can't ever let x be -3. So I'm going to have a vertical asymptote at -3. Okay, because I'm never allowed, if I plug in -3, it's going to break. Okay, so we'll go over that, excuse me, in more detail. And then horizontal asymptotes. So these ones are a little bit more complicated, but right here is a guideline on how to kind of handle them. So, and again, I'm going to walk you through it, so don't worry too much if this doesn't make a ton of sense right now. But basically, what you need to worry about for the horizontal asymptotes is the degree of the polynomial in the numerator and the denominator. Okay, so if the degree of the numerator, so remember that's like if I had an x to the 4th up top and an x to the 3rd on the bottom. The degree of my numerator is 4, the degree of the denominator is 3. So in a scenario where I have the degree of the numerator being less than the degree of the denominator, then it's pretty simple. Y equals 0 is my horizontal asymptote. Nothing to compute, I have my answer. Okay? If they're equal, if the degree on top and bottom are equal, then, so this looks a little confusing. It's really just the leading coefficients of your two polynomials. Again, I'll do an example out, but it's just going to be that line that's your horizontal asymptote. Okay, and then the last one, if your degree of the numerator is greater than the degree of the denominator, you don't have a horizontal asymptote at all. You might have a slant asymptote, but you're not, and again, we'll talk about that in our next lesson, but you're not going to have a perfectly horizontal asymptote. Okay, so let's take a look at the worksheet that I gave you with this. And again, if you can have this sheet easily referenced, that'll be a big help. Okay, all right, so let me pull that one up. I'm gonna pause this video real quick so you don't have to just sit there in silence and wait. Okay, hold on. Okay, we're back. We have this worksheet for today. Let's first, let's just read the directions. It says, for each function, identify the holes, the horizontal asymptote, the domain, and I know this last bit here says this limit behavior at all vertical asymptotes. This software doesn't give me an option to just pick vertical asymptotes, so you're going to ignore this limit behavior business. We're just going to find the vertical asymptotes, okay? And I'll show you how to look at their answer key and see what the vertical asymptotes are, because again, it's got that limit stuff that you're not really going to touch until pre-calc. So any hoosers, let's look at number 1. So we have a bunch of things to find. The first thing we want to do with any of these is factor and cancel if we can. So let's take a look at number 1. I'm going to zoom in a little bit. And let's see. I want to factor that numerator. So in the numerator, I could take out an x, and I'd be left with x squared minus 9. But doesn't that factor some more? So that's just my numerator, right? I could factor that numerator again into x plus 3x minus 3. So I'm actually going to write it here now that I have it nice. So that factors into x times x plus 3 times x minus 3. Okay, oops. There we go. So there's my numerator completely factored. Okay, now let's take a look at the denominator. And I'll switch colors actually for the denominator. Okay, so downstairs I could take out a 3x, and I'm left with x squared minus x minus 2. That's going to factor again into x minus 2, x plus 1. Yep, looks good to me. Okay, so I'm going to put all of that back in here. So 3x times x minus 2, oops, times x plus 1. Okay, now I'm going to erase this side work. I don't need that anymore. Okay, and let's see what I can cancel. It looks like the only thing that I can cancel out are the x's. Okay, now you don't want to kind of annihilate, like sometimes we come in and we really scribble it out and you don't even know what was under there anymore. You kind of need to see it still. So I'm just gonna just do that. So I still know that there's an x under there because it's actually going to come into play. All right, so there's step 1. Factor, cancel out whatever you can. All right, now I think we can talk about the domain. So domain, remember, is going to be all reals except for anything that makes my denominator turn into a 0. So in this case, I can have everything except, oh, you know what, too? Maybe I shouldn't have canceled it out yet. We should have done domain before we canceled. So rewind. Don't cancel yet. Domain, all reals except whatever is going to turn that denominator into a 0. So in this case, if x were 0, my denominator would be 0. The reason why I said, you know, you don't want to cancel it out yet, because if you cancel that out, you might think that 0 is perfectly fine. But it always goes back to the original. Look at my original. If you plug a 0 in, doesn't that make that denominator 0? It absolutely does. Okay, so we always need to consider the original. So I can't have 0, and I also can't have a positive 2, right? Because I have an x minus 2 down there. So if x were positive 2, that would make my denominator turn to 0, so I can't have that either. And same thing here, I can't have a negative 1. So there is my domain. I can have all reals except 0, 2, and negative 1. Okay, so hopefully that makes sense. The next thing we're going to find is the whole. The whole is where I want to look at what I've crossed out. So in this case, the only thing that canceled was the x's. Okay, so now I just asked myself, okay, well, what, this one's a weird one because it's just going to be 0. If I had, for example, if I had an x minus 2 that canceled with an x minus 2, there'd be a whole at positive 2. Okay, not only is there an asymptote there, or I'm sorry, but not only is it not part of my domain, I'm also going to have a whole, and which makes sense, right? Because I can't have that value in my graph. So in this case, I have, the only thing that got canceled out was the x's. And what 0 came from those x's? 0. So I'm going to have a whole at x equals 0. So when I graph this, I'm going to have a little pinpoint hole in my graph at x equals 0. Okay, let's see what's next. Vertical asymptotes. Okay, once factored, any factor in the denominator that does not cancel with the numerator becomes a vertical asymptote. So since my x is canceled, I'm not going to have a vertical asymptote there. I'm just going to have a hole in my graph. Where am I going to have a vertical asymptote? At these two, at positive 2 and at negative 1. So when I go to sketch my graph, I'm literally going to put those dotted lines in at those two values because the graph will never ever touch them. It'll get infinitely close to them, but it won't actually touch. Okay, so vertical asymptotes, which we can abbreviate VA in the future if you want. So vertical asymptotes in this case are going to be at x equals, we said 2, this should be an arrow, x equals 2 and at x equals negative 1. Okay, so there are my vertical asymptotes. Those two factors did not cancel with anything in the numerator, and those are the values that would give me a 0 in my denominator. Okay, so vertical asymptotes in those two spots. And then the last thing we have to worry about is horizontal asymptotes. So in order to do this, you're going to take a look at your original function and you're going to compare the degree. So I have the degree of 3 in the numerator and 3 in the denominator. So in this case, the degrees are equal. So let's refer to your list and then you're going to read what it says if the degrees are equal to each other. So it says right here, if the degree of the numerator equals the degree of the denominator, then y equals a sub m over b sub n is a horizontal asymptote. What? What are they even saying? Okay, this is all it is. It's really not that bad once you get the hang of it. So the horizontal asymptote, since my degrees are equal, it's sometimes I like to just look at this right here. I kind of pretend, as long as everything is written in standard form, it's just going to be y equals that fraction. Whatever those leading coefficients are, that's literally all it is. So y equals, upstairs, my leading coefficient is just a 1, right? There's a 1 there that we never write. So it's just y equals 1/3. That's it. That's my horizontal asymptote. Okay, I know it's a little weird. It's strange to kind of get the hang of this stuff, but That's it. Okay, so, and I think, did we find everything we were supposed to? Let me just read the directions real quick. Holes, horizontal, domain, vertical. Yes, we did the 4 parts. And just a note real quick, on your, on the answers, I mentioned that the whatchamacallit, the answer key is gonna look weird with all that limit stuff. Oh, can I actually pull it up on here? Hold on. So it's the vertical asymptotes that are going to look weird. So this is how we have it written. That's how I want you to write it. Let me just show you how you're going to see it in the answer key. So let me scroll to the key at the end. Yeah, okay. So see all this craziness? Vertical asymptote behavior, So really all you need to be looking for is, we had them where at x equals, what was it, 2 and -1? Yeah, okay. So you're just going to look right here. See how it, on each one it says x equal, or x is going towards, as x, that's how you read it, as x approaches those values. So you have -1, -1, and then you have 2 and 2. That's really all you need. It's just going to be x equals whatever these numbers are. So -1 in this case was one of them. Oh, oh, my pen stopped working all of a sudden. And then x equals 2. All right. Don't worry about the little positive or negative sign after. It's just the number in front. I know it's weird. Sorry, I don't have an option to just do a normal vertical asymptote without these limit things on the software. Okay, so any hoosers, there's that. Let's go ahead and try the second one. Okay, so number 2. So first thing I'm going to do again is factor the top and the bottom. This one's actually a little bit simpler to factor. The top is just the difference to perfect squares, so that's just x plus 3, x minus 3. And then, oh geez, my denominator, I can just take out a 4 and I'd be left with x plus 2. Okay, so first let's talk about domain. So domain is going to be all reals except for whatever makes my denominator turn into a 0. And the only thing here is going to be a -2, right? That's the only thing that's going to make my denominator turn to a 0. So I'm going to have all reals except -2. Everybody agree? I'm asking like I can hear you answer, but I'm assuming you're saying yes, yes, that makes sense. Okay, now we're going to check if there are any holes. So to check for a hole, we need to look at whatever factors cancel in the numerator and denominator. Well, none of these cancel, right? None of my factors cancel with anything on the bottom, top and bottom. So that means that this graph just isn't going to have any holes. So holes, none. Okay, next up is the vertical asymptote. So once factored, any factor in the denominator that does not cancel with the numerator becomes a vertical asymptote. Okay, so nothing canceled, so I have to consider everything that's still here that is not making, that's going to make my denominator be 0. And we already said it, it's going to be -2. So I'm going to have a vertical asymptote at x equals -2. Okay, and then we're going to do the horizontal asymptote. So let's see, this is where we have to go to the original and we look at the degrees. So in this case, I have 2 for my degree in the numerator, and the denominator, it's just a 1, right? So that's the first degree. So in this case, the degree of the numerator is greater than the degree of the denominator. So I refer to my note sheet. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, so I do not have one. Maybe we have a slant asymptote. I don't know. You'll have to tune in tomorrow. Okay, but I don't have a horizontal one. Okay, does this make sense? I'm hoping a little bit. Let's try another one. Okay, number 3. Let's see what's going on here. So I'm going to start off by factoring. There's nothing to factor in the numerator because it's just a 1. But downstairs I could take out a -4 and I'd be left with x plus 4. Okay, there we go. So we did the factoring. Domain. Is there anything that I could plug in for x that would make my denominator turn into a 0? Yes, -4. So my domain needs to be all reals except -4. Okay, so domain is done. Next, we're going to talk about if there's a hole. So holes only happen when a factor gets canceled, right? And this one, again, doesn't have any. So when I go to cancel these, there isn't anything to cancel, so there's no holes. None. Okay, next up, the vertical asymptotes. So again, now I look at my factored version after I've canceled everything out, and again, there's nothing to cancel. So now I just want to state that I'm going to have a vertical asymptote at any x value that makes my denominator 0. So again, we've already said it. It's just going to be x equals -4. There's my vertical asymptote. Get to move on. Horizontal asymptote. Now you have to go to the original and look at the degrees. So what's the degree of the numerator? If you're saying 1, you're incorrect, because what's the degree of the denominator? The degree of the denominator is 1. So in order for there to be a degree of 1, you need to have a variable. I don't even see a variable in the top. So what does that mean? That means its degree is 0. Right? Because there is a variable there. It's just x to the 0 power, and x to the 0 power is just 1, so it goes away. So the degree of my numerator is 0. The degree of my denominator is 1. So that means that the degree of the denominator is greater than the degree of the numerator, or I should say that the other way around. The degree of the numerator is less than the degree of the denominator. So we're looking at the very first bullet on your note sheet. And when that happens, when the degree of the numerator is less than the degree of the denominator, you have y equals 0 as a horizontal asymptote. Don't need to compute it. It's always just going to be y equals 0 if you have that scenario. Okay? All right, let's try one more together. Okay, so let's start off by factoring. The top factors into x plus 2, x minus 1. Oh, geez. Oh, no, stop. When I write too close to the top, it keeps like pushing buttons that I don't want it to push. Okay, so there's my numerator completely factored. Downstairs, I can take out a -4 and I'd be left with x plus 3. Okay, man, again, nothing cancels. That's not always going to happen. So plenty of times you have things that cancel, but let's start off with our domain. It's going to be all reals except, does anything make my denominator turn into a 0? Yes, -3. So all reals except -3. Okay, hole. I don't have a hole because nothing canceled out, so none. Vertical asymptotes. That's just going to be x equals whatever makes the denominator turn into a 0 after you factored. So x equals -3. And then for my horizontal asymptote, let's check out the degrees. The degree of my numerator is 2. The degree of my denominator is 1. So the numerator is greater. I have no horizontal asymptote. That's it. Okay, so I left 4 for you guys to try. So give them a shot. Let me know if you have questions. I know it's weird at first, but once you get the hang of it, I think you'll be all right. Okay? Let me know.